Welcome to this tutorial. This is Gwiza again, and today we are going to talk about doubly linked lists. And as we have seen to the previous tutorials, we have been talking about linked list, or what we call singly linked list. Then today we are going to talk about this variation of linked list, so in which the navigation is possible to both ways. Usually, what is a doubly linked list? Assume that we are having here, this is the first node, second node, third node, and even the fourth node. Usually, this is a singly linked list. So why is it a singly linked list? Usually, the navigation is done only in this way, which is a forward navigation. And this forward navigation, it is having some challenges. Sometimes if you are like here, for you to be back to this one, it causes some problem. It gives you some challenges. So then here we are going to talk about a doubly linked list, in which this one will be having another link to the previous node, and this one will be pointing to null as well. So it means if you're like here, so to go here it is very easy, and to come here it is very easy. So then it means then on our declaration, how are we going to define our structure? The structure definition will be done the same. So usually here we'll be having struct node, and in our struct node we'll be having, for example, int data, which is a variable that will be holding for us our data, and also we'll be having our next and our previous, which means struct node next, and also struct node previous. So it means then from here, what are we doing? What are we doing here? Usually it is like saying I am going to have a node, but this node of mine will be having next and previous. So then let us go to practical things. Then I will be explaining everything when we'll be doing some practices of those things. So the first thing, as you know, in C, all the applications or the programs in C should be having some parts, and the first part is the preprocessor, and the second part is our function. But then before this function, let me call my program. Let me call it, for example, doubly linked list. Doubly linked list. And here, before I do this, I need to define my structure, which is struct node, and inside my structure, the structure element, I'll be having my value, which can be int value. Then together with this, I will be also having my int, I can have a self-referential struct node next, and also struct node previous. Usually, as you can see, these are the pointers, and my pointers, I'll be having the pointer, let me call it only prev so that it will not be long. I'll be having my pointer to point to the next node, and my pointer to point to the previous node. It is as the same as what I did here. This is what I have done here. So usually this is what I wanted them to do here. I said then we know that then here there's something that we are going to do. We are going then to use malloc. So it means then we need to import or to use or to define the preprocessor for our dynamic memory allocation. So the dynamic memory allocation concept has been discussed in the previous videos. So you can refer to the videos or to the video that will be talking about DMA. You can go to my YouTube channel, then you'll be finding that video. So then here I need also to have, I want to have like a global variable and my global variable, my global pointer, it will be head, and it is the one that will be pointing to the first element from my list. So for the first time I am assigning null to it, because when you are declaring a variable and you don't assign or initialize anything to it, sometimes it can have any ASCII value which can be null or not null. So it means then for us to be sure which value does this has, then we need to put to initialize the variable that has been created. So apart from head, also we also have another one which is called last, which will be the one to point to the last node, and I can also have the other one which is current, that will be helping me to hold on or just to see what is the current node. Okay, so then I am going to first start with the definitions of my functions. So then the first function, it is this function which is empty. I want to make sure if my list is empty. So then here, as we know is empty, we can say okay, it can be either true or false. Is it empty or it is not empty? So it means then the return type or the return type for this function, I'm going to make it, let me make it Boolean, because it will be a bool. Then here, let me return something. I will return my head which is equal to null, which means if then my head is equal to null, then it is empty. Okay, so then here I can say okay again, let me say for example I want then to check the length of my list. So if I want to check the length of my list, I will be using this current one, because I will be navigating from where I was to the current, from the head to the current. Then I need to, let me create another function, and let me call it int length. So my int length, okay, there is no need to have a parameter here, just because I am able to access to the head and also to the current, because these are the global variables. So what am I going to do here in my length? So usually I can say okay, let me have like int len which is equal to 0, and this len, it means length. It is the one that will be helping me with the length. Then here, as we can see here, we are having okay, we are having this let me create, I'm going to create like another pointer, and my pointer, let me call it struct node current. Then my struct node current, after this, then I need to use a loop that will be helping me to loop from my list, and my loop will be going from the initialization. My current will be equal to head. Usually it is going to take the head or where head is pointing, and then I will be going till my current will be not equal to null. So it means as long as I will be going to where current or my pointer is going to be a null, then the loop finishes. It means the condition becomes false. It will only be true if my current is different to null. Then here, what is the incrementation? I will just take my current to be equal to current dot next. I don't know whether you are getting my point here. So usually my loop will be going, the initialization will be from to have the head pointer or where head is pointing. Then also it is where my current is pointing. Let's illustrate this one, but let me first do this. Let me just, okay, let me say that my length, then it is going to be plus plus. As long as my current is different from null, then let me have this to be incremented. Then after everything we need to return my len. Okay, this is it, but then let us just illustrate this in here. So it means then, for example, here I had my list. Usually the previous is like this and the next is like that. So my head usually was pointing where? Was pointing here. Whatever I done, I created another pointer which is equal to the head. Where head is pointing, it is where also my current was pointing. Then I'm going to navigate till I will be having my current then, which is equal to null. Usually if it becomes null, then I will be going out of the loop. And then here I had a variable called len, and that here it was 0. As long as then there's something, then it increments itself. So it means then it will be reaching here when it will be telling me that I have how many nodes? I have 4 nodes. So it means then this is my function, the function to count my nodes. So then here, as you can see here, it is very easy. It is very easy as long as you are having your nodes. It is very easy to display in 2 ways. And I am going first of all to show you how can I display forward. Usually display forward, it is the function that we all uses in even in single linked list. So it means you'll be using our head, and where head will be pointing, then we navigate through till we'll be having where our next is equal to null. So we need to start from the beginning usually. Then I am going to start with this one. So let me say, okay, I am going to have my function. I don't want to return anything, and let me call it display forward. And in my display forward, usually I don't need any parameter because all of them, they are global variables, and then I can access to them. Usually then here, as you can see, so that it is not allowed to navigate using head. So it means we need to create another pointer, and let me call this pointer PTL, and this pointer is the one that will be navigating through my list. Because if you navigate with the head, there can be a problem. The problem can arise, and then you lose everything. But as long as I know that my head is there like a backup, anytime then I can come back to the head, right? Yes. Then here I need to come here. Okay, I need to create another pointer, struct node PTR. And what is the role of PTR? PTR will be holding for me where head is pointing. So after this, then I need to navigate through there. So then here, let me first assign PTR to where head is pointing. Then here I need to have the loop, and this loop will be helping me to navigate to the end. No, sorry, not to the end, but to navigate through from the beginning to the end, but by printing the data from whenever I will be. Okay, let me say that, okay, let me use a simple loop, which is while loop, and I will say, okay, while PTR is not null. I can only say while PTR, or I can also say while PTR is not null. So it means then while it is not null, I can print out something. So then what should I print out? I should print out the data to where PTR is. For example, if I say PTR is pointing here, and here we had like 10, here we had 20, here we had 30, here we have 40. As long as PTR is pointing here and PTR is not null, I'm going to display out the ptl.data. Yes, it means then here I need to display ptl.data. And this data, usually it is this one here. It is not data, it is value. Okay, but here sometimes we can say, okay, I want them to know also the index where it is. So usually you can, okay, let me add, for example, I'm going to add something like key that will be helping me to know the index. Let me call it int key. But in my insert I need to know, okay, in my display forward, then I can say, okay, let me put them like in parentheses so that it will be very easy to be seen. There I put something like this, then I put again, so I can say, okay, now it is then ptr dot key together with the ptl dot value. So it means the key is this one and also the value is this one. And what should I do then? I need to take my ptl to ptl.next. So I say ptl is equal to ptl.next. Then after assigning this one, so I can say, okay, this is enough. So this is my display forward. You can see that it is the same as the other display in single linked list. But in order to avoid confusion, let me leave this one, and I only have one value. So it means then on my display, then my display will only work like this in order to avoid these confusions. So before I continue on this, let me first work on the insertion, because insertioners they are very key and they are very useful. And let me say, for example, I'm going to start with insert at the beginning. In my insert at the beginning, I will have something like let me, on my insert at the beginning, let me have the value to hold my the pointer or the node that would be getting for me the value, and let me only call it this one. I'm only going to use this one because these are what we call local variables. Even if I have declared it here and here, it will not be known because they are local. Okay, after having my ptr, let me have also my int, let me call it item, which will be holding for me the value that the user will be entering. Then I am going to allocate this dynamically. Let me say ptr is equal to malloc, and in my malloc, then I'll be having the size of my struct node. But then because this returns void pointer and I want struct pointer, I need to typecast, and my typecast will be struct node pointer. So it means then I am only typecasting the value to be returned by my malloc function. So after then, usually because we are using dynamic memory allocation, so it means then there's no way our memory will be full. But there is only one challenge that can happen. If our space or the size of our disk or our storage is full, so it means then After locating like this, it will stay null. So we need to check if it is still null. So if it is still null, we say that our memory is overflow. So usually we say, okay, then if my PTR is equal to null, then I will say, okay, I will tell to the user, that the memory overflow. Let me say, for example, I will say memory rate overflow, which means there's no way you can create a new memory. So then here, let me come with my else statement. And my else statement, then I need to check, okay, I will need to tell to the user, okay, printf enter a value to insert. Then after telling to the user to enter a value to insert, you understand that I need to use my standard input method or function, which is scanf. And my scanf, I'm going to receive it as an integer. This is why I need to put this data type specifier of integer. Then I receive my what? My item. But as you know, as long as it is not a character or a string, you can also see this in my previous video. Why do we need to put this address sign before an integer variable when we want to receive a value for that? So then, okay, after this I need to check if then head is null. So if head is null, when head will be equal to null? When head will be equal to null? It is when there is nothing. So if it is null, then what should I say? I will need to take my PTR. I will only take my PTR dot next, then I assign it to null. Then also my previous PTR.prev, also it will be equal to null. But then my PTR.data, it will be going, and then it takes what? It takes item. So what have I done here? Usually this is what I'm doing. So I'm saying, okay, let me have my PTR, and PTR dot data is going to receive an item. So let me say that the value that the user entered is 10. So then if my head was equal to null, so it means head was pointing nowhere. What should I do? I will only take my PTR dot next null dot previous null, and also my head is going to come and then point to PTR, but after having my PTR dot data, which is equal to the item. So it means then here the remaining code, it is to say then let my head point to PTR. This is what I need to say. It is equal to PTR. So it means it is when head is equal to null. Then here I need to check on my else it means then my head was not null. Usually I need to check on this. Okay, it means then here we had something. Here we had something like this, and then our head was pointing here. Let me say that here it is 10, 10, 20, 40. This is an example. Then it means then I need to check on this. What have I done usually for the first time? Remember that there's a variable called, let me say it is having 100, and it is called what? It is called item. And there is a memory block that I've created, which is equal to PTR. And remember that, okay, we are going to insert where? At the beginning. And okay, what am I going to do? The first thing that I'm going to do, I am going to take my PTR.data is going to be equal to item. It means then it is going to have 100. After having 100, then my PTR.previous, I assign it to null. Then what should I check? Then I will take then my ptr dot next. It is going to point where head is pointing, and also my head dot previous, which was pointing to nowhere, it is coming, then it points to ptr. Then head will be deleted from here, then my head will be pointing where? To here. Excellent, this is very good. So what am I going to do then? Here on my else, I'm going first of all take this ptl. Okay, let me copy this code. Usually I am going to first take my ptl dot data is equal to item, then my ptl dot previous, my ptl dot previous, it is going to be equal to null. Then my ptl dot next, it is going to point where? To point where head is pointing. Then my head, my head dot previous, it will be equal to ptr. Then after this, then what should I do? I need only to change where my head was pointing, and my head will be coming then where ptr was. So this is what we mean by insertion at the beginning. After insertion at the beginning, what else should I do? I need then to do what? To insert at the end. What should be done to insert at the end? The same practices. I will create a ptl here. After this ptr, then I'll need to navigate. I will assign here, like, let me call it temp. That will be helping me to navigate through the list till it will be going where the list dot next is equal to null. And whenever it is equal to null, what should I do? I will check when it is not, when it is equal to null, I would say, okay, let my temp dot next equal to ptr. Then my ptl dot previous, it is going to be equal to where my temp is, and then my ptl dot next is equal to null. So there's no need to put head as long as head is still having its location. Very key and very good. So it means then, what am I going to do? What am I going to do here? I am going only to create the same, to copy this. After copying this, then I'm going to paste it here. It is insert at last. So on my insert at last, the same thing that I'm going to do, it is the same. If this then overflow, then enter the value to enter the same. If head is equal to null, the same understanding. So then on my else, then it is going to be different. On my else, I have created, let me create, for example, another ptl. Okay, here ptr, comma, another pointer which is equal to temp, for example. So then here, well, what should I do? I will only take my temp, and then I assign head to it. It means it is going to point where head is pointing. Then after this, I need to use a loop, and this loop will be going from here, from where head is, to the last node. What will be the indication of the last node? The last node will be pointing to null, right? Okay, it means then I will go till my next is equal to null. So temp, while temp dot next is not equal to null, so it means the navigation will continue. What will be done in the navigation? Usually, what should I do? I will only be taking my temp to be equal to what? To temp dot next. Very good. So after this, then I will be going to the last node. After going to the last node, I will say, okay, please, you temp next, please temp next. Where are you going? You are going to point where my ptl is. And then I will say, okay, as long as then my ptl, then let me say, okay, then okay, ptl previous, ptl prev. What are you going to do? ptl prev. So please come to where my temp is, and then after this I will say okay, as long as then I have finished with this, then my ptr then ptr.next, it should be equal to null, because I need to know the last node, and the last node will be known according to what, when its next is equal to null. So here you can put the message, you can here put the message, and this message I can say okay, it is only to tell to the user that insertion successful. Okay, it means then I have finished to insert at the beginning, to insert at the end, to display. Then what else am I going to do? What am I going to do here then? I am going then to say, can I insert at a specific position? Yes, the same. It is very easy. So let me just come and then copy again my last node. Then I'm going to paste here. I'm going to call it insert position at a specific position, or insert at a specific space position. Let me like this. Okay, the same, I will be having my ptr, my temp, and also my item, but also here on my int item I will also need to say okay, I will need also the location and also my I will show you where this will be used from. And from here I will check, is my memory not overflowed? No. Then okay, is my head null? If null, the same insertion, because there's no mean to go to the third node yet, there is no third node. So then here, when then this finishes, I need to come here, then I say okay, it has already finished. Then I need to come to my else, and then on my else I need to go to that specific position, right? So here I need to ask to the user, after this my temp is equal to head, and then I will say okay, guy, Mr. User or Miss User, okay, please enter the location. Please enter the location. So after entering the location, then I need to receive that location that the user has entered, and my location will be an integer, and as long as it is an integer I will be putting the percentage sign now to take the location. After this, then I need to put a loop, and my loop will be going from where it will be for I to be equal to 0, and my I should be less than the location, because okay, if I say I want to put the location 5, I need to loop till 5, right? Then I plus plus. After having my location, then for me to get to the location, if the location is not yet, I will take my temp to have temp next. So sometimes then the location can have, you can put location 10 when the location is only limited to 8 or 6. I need to keep track to it, and I say okay, then if my temp comes to where it is equal to null, so it means I've finished the navigation. So I need to notify to the user that the location that he or she has putted is not valid. So we say, let me put only invalid location let me say %d is an invalid location. Then here we tell okay, location is not true, it is not good, and from there I need to return. So then okay, good, we have gone, and then we have reached where the location is. So the same I will tell to the user here, okay, here I have finished to put to tell to the user to put the value. Then here I have finished to take my value. Then I will say okay, because here temp has been used before, let me use ptr. Yes, it is ptr. After my loop, I need to say okay, let my ptr it's already has this one. No, it is if null. Okay, let me say okay, then my ptr dot data is equal to item. After putting everything in my ptr dot data is equal to item, then I will say okay, my ptr dot next, which is the other one of mine, is equal to what? To temp dot next. I will explain this very well. After having this, then I will say okay, then what about then my ptr dot previous? My ptr dot previous, it will be equal to temp. After doing this, then I will say okay, then what about temp dot next? My temp dot next, it will be pointing to where ptr is, and then my temp dot next dot prev is equal to ptr. My temp dot next again dot prev is equal to ptr. Let me explain this what I have wrote, and remember that okay, at the end of everything we need to say successfully inserted. I don't know whether all of these things has their closing, but I think so, yeah. Okay, let me explain then what I'm doing in here. Usually what am I doing in here? I have said okay, this is my normal list. Let me say here we have 10, 20, 30, 50, then 60. Okay, I have said okay, I have forgotten 40. Then I have created my ptr. So when it is empty, so it means there's nothing here. Usually it is the same insertion, but it is not empty. Remember that here I'm having something that I'm calling my value, and it is where the user has inserted 40, which is the number that has been previously ignored or forgotten. So I'm saying okay, let me my ptr.data equal to what? Equal to 40. After having my ptr.data is equal to 40, then I will say okay, ptr.next, then it is going to be equal. So just cause here I will say I want to my location where temp will be, it will be here. This is where my temp is. Just cause here I have navigated through the list. As you can see here, I have navigated through the list and I have reached where the location is. So then here I need to come then okay, my ptr.next, it is going to be equal to temp.next, because temp.next is this one. This is temp next. This is my temp.next. And okay, after having this ptr.next, which is equal to temp.next, I will say then what about the ptr.previous? Ptr.previous, it will now come here. So you can see that here between this and this, there is between this and this there is this 40, but you can see that here I am having only this one. I need to put another link. Then what is this link? Then I will say okay, then my ptr, no, my temp.next is equal to previous. Then okay, not to previous or to ptr. My temp.next, then it is going to be here, and then I will say then what about then temp.next.prev. The previous temp.next was this one. Then the temp.next.previous, the previous of it, I will just take it to here. So now I will be having 30, 40, then 50, just because 40 is, as you can see, it is having the two links, and also these two links. Very good. It is now very good. Then I will tell to the user now, okay, it is successfully inserted. Okay, so this was insert at a specific position. And here also we can have our delete. Let me say that then we want to delete, but also we can delete at the beginning, we can delete at the end, we can delete anywhere. So let me say that, for example, here we want to have our delete. Let me say let me call it also void delete, but then delete where I want to delete from the beginning. But usually, as you can see, these nodes, they are not useful. I better remove them. They are not useful. Let me say that we want them to delete at the beginning. So usually the same, I will need my struct node ptr, and then my ptr, I will say okay, when will it be underflow? It is when head is equal to null. We say okay, if my head is equal to null, so it means then I will tell to the user, okay, I can say underflow. Underflow means there is nothing in our list. Secondly, I am going there to put my else statement. Then in my else statement, I will need to check, I will need to delete them from the beginning. How the deletion from the beginning will be done? How will it be done? Usually there can be a time, let me say only we are having this one and this one, and here it is our head, and we are having only, for example, 10. So it means we don't need to say the remaining part should be having this and all this. We need only to destroy our list. When will it be done? In my else, I need to put then if, let me use else if. Then here I can say okay, else if my head dot next is equal to null. So it means there is nothing at its next. What should I do? I will only come here, then I say okay, head please now be null. After putting this, I can say okay, now I can even just free head, because head is not now having anything. After freeing head, then okay, I can just tell to the user as the notification, I say okay, node deleted successful, finished. I have finished to delete my node. So after this, then okay, I can say wow, no, then what about then if there's another thing in our list? What are we going to do? Usually we say okay, ptl is going to be equal to my head, then I can say Let me take even my head to my head next. Then I say okay, head dot previous is going to be equal to null. Then I can free ptr. Then I say okay, the same node deleted successfully. I have finished. Usually there is no big deal in deletion. So you can say, okay, now I have seen that you've finished to delete from the first one, from the beginning. What about deleting from the last element? I say, okay, delete from the last. What will be the deletion from the last? The same. If head is equal to null, then I will say underflow. Else if the same, but then on my else what should be done on my else? Then here we say okay, let me put another if, which will be if when it will be if my ptr dot next is not null. I need to navigate through my list, then I will go to the last one. Then what should be do? I will be doing what? My ptr will be going to be equal to ptr dot what? Dot next. After navigating like this, then I will reach to the last element. After the last element, I will say okay, my ptr dot previous dot next, it is going to be equal to what? To null. So it means I am freeing this one. Then here we say okay, then I have finished to delete the last node, and then I need to free my ptr, which means I have finished to delete it. Then here we say okay, not successfully deleted. Then I have finished to delete. Because I have gone to the last node, I have then deleted that last node. Okay, after this then I can say okay, then what about then deleting at a specific position? Deleting at a specific position. Deleting at a specific position, it will be also like the same, but only for the else. But then here on my else part, it is where something is going to change. On my else part, the first thing that I will tell to the user, I will declare a variable called var. After this var of mine, I will tell to the user printf enter a value after which the duration should be made. Then after telling to this user enter value after which the deletion should be made, I need then to come here %d, then I receive what? I receive my val. So after receiving my val, then I will say okay, my ptr is going to be equal to head. Then while then ptr dot data is not equal to var, my ptr they need to take ptl.next. So then after this I will need to check then if then I will finish if ptl.next then is equal to null, if ptl.next where I was is equal to null, then I will say I need to tell to the user that the deletion cannot be made because the element that has been specified is the last. I will need to tell to this user can't delete because the specified value is the last. It is the last one, so it means we cannot delete. But then on my else if, what should be done? On my else if here we say okay, then my else if ptl.next is equal to null, if my ptl.next 2 times is equal to null, so I will only delete without taking care of the remaining. I will delete without taking care of the remaining part. So it means there is the node that is needed to be deleted is now the last one. So it means we will not keep the remaining list. So what will I only do here? I will only say okay, my ptl.next is equal to null. ptl.next is equal to null. Then when it is in the middle, then on our else it is when it is in the middle. Now if it is in the middle, then what should be done? Usually I will take my temp, I will create, I think I have created here a variable called temp. There's no temp here. I need to declare another one which is temp. I will say okay, then my temp, it is going to have ptl.next. Why? Because I need to keep on the remaining part of my list. Then I say then ptl.next is equal to temp.next. I think you are getting this. And also here we say okay, as long as then here you can see that my temp have came and then it has taken the temp.next, then ptl.next is going to be equal to temp.next. It means it is like jumping one. Then here I will say then temp.next is going to be equal to what? Temp.next.previous is equal to ptl. Wow, this is very good. It means then I have here ignored one node. I will only free temp. Very good. It is a very understandable logic. Can I explain? Yes, let me explain usually what am I doing in here. So for the first time we have said okay, the deletion, when the deletion should be done, we have said if we had like only this one and our head was pointing here, so it means then we want to delete, for example, delete one element, we will delete it directly. Secondly, we say then let us delete from a specific position. We have said then we want to delete, this is 10, this is 20, this is 30. We have asked a user, please specify the value to which the deletion should be done at its next. So for example, the user said 30, so it means the user wants the node next to 30 to be deleted. So it means then it cannot be possible, because next of 30 there is nothing. It is where we have said here, it is where we have said here, can't delete because the specified value is the last one. Then we have then another scenario. Which scenario? So what if then, like here, so here it can't be deleted, as you can see. So I have closed my if. Then in my else if, then I said, okay, what if then the user has putted 20? So then it means 20, I don't need to keep track to the remaining part, just because I will only say, okay, the user wants to delete the number after 20. I will only say the next of it, let it be null. So it means the whole part will be deleted. This is what it is written in here. So this is what I have wrote here. I said, okay, if then my ptl.next is equal to null, my ptl is this one, it is where it is. I said ptl.next, next. So it means it is null. Now I will only say it is equal to null. Are we together? So assume then, assume then these all things are not there. So assume then the user have said, the user have said, I want to delete after 10. So if you want to delete the number after 10, you can see that here there is another list that we need to keep track. So what should be done then in here to what I said. So usually I will say, okay, this is where my ptl is. Then I will say, okay, let me create another variable which is called temp, and my temp is going to be equal to ptl.next. It means then my temp is going to point here. Then after having my temp which is pointing here, I am saying then, okay, let me then my temp.next.previous is equal to ptl. So here I said, okay, my ptl was where? First of all, ptl was here, then I said temp is equal to ptl.next. Then my temp.next.previous, which is this one, it is going to be equal to ptl. So then here I will say, okay, then what about then the temp.next.previous, it is equal to ptl. Then I will free temp. So it means then I am going to free what? I'm going to free, just because here I have said this is going to be equal to ptl. Remember that ptl is where? Is previous here. So I said let my temp.next.previous, this is my next, which is temp.next is this one, then its previous, it is going to be equal to ptl. Then it has came here. So it means then I have just already linked the two nodes. Then this one is like ignored. I will free temp because temp it is the one that I was pointing there. Good. Then my display, I will need to say, okay, then what about then my display? So then what are we going to do then? So as long as we have finished to insert, to display, and to delete, then we can also search, we can do something, but let us go to the main, and we are going then to build our main. And for the main, I think it is not a big deal, so everyone can do it, right? Everyone can do it for the main. So I'm going to pause as I will be writing the main because of the time. Then I will be explaining to you what is that main do. Okay, I'm done with the main menu, and as you can see, then let me explain how the main menu is done. Usually it is the format of what I want. So here I said, okay, this is the main menu, choose your option, then you need to choose from 1 to 8. Then I receive the choice, then I switch the choice. For 1 it is insert at the beginning, insert at the last, insert at specific, insert at the beginning, okay, delete at the beginning, sorry, delete at the last, delete at specific, display forward, then also exit. Okay, this is my main, and if I run, then you can see that okay, it is showing. So insert at the beginning, display, show, insert after given, insert, okay, everything is there. So if I say 1 to enter the value, then it is there. 1, enter the value, it is there. 1, enter the value, is there. Let me click on 7, which is display, so you can see that it is printing all of my values. So thank you so much. Thank you for watching this tutorial. I will give you the source code in the description below, and you can download them and use them as you want. Thank you so much. Thank you again.